Now let us study about the next theory topic of this chapter 4, last theory topic. It is uniform circular motion, most important topic. So what is uniform circular motion? The meaning of uniform means constant. So if you find one particular object is moving on circular path with constant magnitude of velocity, that means constant speed, then it is known as what? Uniform circular motion. The motion of an object moving on circular path with constant speed is known as uniform circular motion. For uniform circular motion, the acceleration is centripetal acceleration. Centripetal means center seeking. From every point of the path of circular motion, the direction of acceleration is towards the center. The particle is here along this center direction, acceleration. Particle is here along this center direction, acceleration. Particle is here along this direction of center, the acceleration is there. It means what? From any point of the path of circular path, from any point of the path of circle, in the direction towards the center, there is an acceleration, and that acceleration is known as centripetal acceleration. So we derive the equation of centripetal acceleration. So suppose an object is moving with uniform speed v in a circle of radius r as shown in figure. So here there are three figures. This is one figure, second figure, this is third figure. Here the center C is there. This is the entire circular path. No necessary to draw the entire circle. Here little bit circular path is drawn. C be the center, and on this circular path the particle, or you can say the object, is moving with uniform speed, that is constant speed v, and the circle having a radius equal to r. Since the velocity of the object is in the direction of tangent drawn to the curved path, at that point direction of velocity continuously goes on changing, but its magnitude remains constant, and hence the object is in accelerated motion. So we know very well, in case of circular path, at every point of the path in the direction of tangent there will be a direction of linear velocity. If particle is here along the direction of tangent, linear velocity. Particle comes here along the direction of tangent, the linear velocity. So direction of linear velocity continuously goes on changing in circular path. And we know very well, when your either magnitude of velocity, direction of velocity, or both changes, then it must have a definite acceleration. So here the velocity of an object is in the direction of tangent drawn to the curved path at that point, and this direction of velocity continuously goes on changing, but its magnitude remains constant, and hence the object is said to be what? In accelerated motion. That means such an object has a definite acceleration, and this acceleration is how much? That we find. So let us find magnitude and direction of this acceleration. To find this thing, we consider this figure. Center C is there. T be the position of an object at time t. P dash be the position of the same object at time t dash. Cp is the position vector of the point T with respect to center at time t. R dash is the position vector of the same object at time t dash. In this direction of tangent, velocity is v. In this direction of tangent, velocity is v dash. So vector v and v dash, so these two vectors are different in direction, but magnitude is same. Suppose here it is 10 meter per second, this is also 10 meter per second, but here the direction along this tangent, and here the direction is along this tangent. As shown in figure, let vector r and r dash be the position vectors, and vector v and vector v dash be the velocities vector of the object at points p and p dash at time t and t dash. So these are at two different, one at time t, another at t dash. If I say t is 4.0 second and t dash is 4.5 second, so t minus t dash is 4.5 minus 4.0 is 0.5 second is time interval. Velocities at point is along the tangent at that point on a curved path in the direction of motion. मोशन ये डायरेक्शन में है, इसलिए ये डायरेक्शन में along the tangent velocity. अगर मोशन इस डायरेक्शन में होती तो यहाँ से ये डायरेक्शन में along the tangent velocity होती है. Using the method of triangle for vector addition, now we obtain the sum of the two vectors. So one is, so this is vector r, this is vector r dash. From the tail of this first vector, that is from the point, you join the point with p dash, put the p dash at a point p dash arrow. According to method of triangle, vector cp plus pp dash equal to vector cp dash. Vector cp is vector cp is r. I denote pp dash is delta r, and this cp dash is r dash. So vector r plus delta r equal to r dash. Means delta r is equal to r dash minus r, and r dash minus r is change in position vector. Similarly, you can also obtain the change in velocity. Just I consider this is one more point G is there, and from the point G I draw an arrow parallel to vector V. From the point G I draw an arrow parallel to V dash. By joining the head of these two vectors from this point to this one, so I say this is delta V, it is a change in velocity. Guessing by method of triangle, this is one vector, from its head this is another vector, so vector V plus delta V equal to V dash. So delta V is equal to क्या मिलेगा आपको V dash minus V. तो thus you are getting there are the two vectors by method of triangle. So using method of triangle for vector addition, change in position vector, and you know change in position vector is known as displacement vector delta r, and change in velocity vector delta V are obtained as shown in figure. So delta V is in this direction, delta r is in this direction. How they are located? You can see it from the diagram, they are perpendicular to each other. So because of position vector and radius, that position vector that is radius and vector V are perpendicular in circular path. That's why delta V and delta R also becoming perpendicular to each other. Since the path is circular, vector V is perpendicular to vector R. So vector delta V is also perpendicular to delta R. And from the direction of delta V, we can determine the direction of average acceleration. Average acceleration, average A equal to, as we know, delta V by delta T. So this average acceleration is in which direction? It is in the direction of delta V. Delta V is in which direction? It is in a direction perpendicular to delta R, and it is going towards the center of a circle. So here you can see that the average acceleration equal to delta V upon delta T is along the direction of delta V. Average acceleration is along the direction of delta V, and delta V is in the direction towards the center. So we can say that average acceleration is directed towards the center of circle, and as it is directed towards the center of circle, it is known as centripetal acceleration. You also remember one more point. If you take time interval delta t tends to 0, so here at point P I am taking the time t equal to 4 seconds. At P dash I am taking the time t dash is 4.5 seconds. So time interval is 0.5 seconds. But if I reduce the time interval, instead of 0.5 seconds, 0.4, 0.3, 0.2, 0.1, 0.01, then what happening here? This kind of the later position of the particle, this kind of the later position of the object comes very close to the initial position, and in that case you will find this direction of linear velocity is exactly perpendicular to the radius, and in that case along the direction from P to C there will be a centripetal acceleration. So we have to make the use of this figure 3. So be remember here, but this is the figure 3 when delta t tends to 0. As I said earlier, if time interval delta t, that is t dash minus t tends to 0, then average acceleration according to definition becoming instantaneous acceleration, and this instantaneous acceleration is directed towards the center as shown in figure 3. Thus, in uniform circular motion, the acceleration is always directed towards the center, so it is called centripetal acceleration. And now we find the magnitude of the centripetal acceleration. The magnitude of the centripetal acceleration is modulus of vector A equal to limit delta t tends to 0 of modulus of vector delta v upon delta t. Now if we say delta theta is the angle between vector r and r dash, you have seen in earlier diagram, vector r was like this one, vector r dash was like this one, delta theta was the angle. Same angle theta you will get between vector v and v dash. So if delta theta is the angle between vector r and vector r dash, since velocity vectors v and v dash are perpendicular to position vectors, तो अगर ये परपेंडिकुलर है तो दो रेडियस के बीच का जो एंगल है, दो पोजीशन वेक्टर के बीच का जो एंगल है, वही एंगल आपको दो वेलोसिटी के बीच का मिलेगा। मतलब जहां पे आपने टेंजेंट्स ड्रॉ किए थे वो दो टेंजेंट्स के बीच का भी मिलेगा। सो इफ डेल्टा थीटा इज द एंगल बिटवीन वेक्टर r and vector r dash and velocity vectors vector v and v dash are perpendicular to position vector, then the angle between them is also found to be delta theta. एंगल between them मतलब between v and v dash, तो आपको डेल्टा थीटा एंगल v and v dash के बीच में भी मिलेगा। अब वहां पे आगे जो आपने डायग्राम देखा उसमें दो ट्राइंगल थे, ध्यान से देख लीजिए फिर से आप। वन ट्राइंगल पोजीशन वेक्टर्स को ज्वाइन करता हुआ r dash एंड डेल्टा r को cpp dash, एंड वेलोसिटी वेक्टर्स v dash एंड डेल्टा v को ज्वाइन करता हुआ ट्राइंगल है ghi। तो आपको दो ट्राइंगल मिलते हैं, the triangle cpp dash obtained by joining the position vectors and delta r, another triangle ghi obtained by joining the velocity vectors and change in velocity are similar triangles. And as they are similar triangle, for similar triangles what should be there? There is a always common factor is that the ratio of the base length to the side length for one of the triangle is equal to that for the other triangles. Therefore you can write modulus of delta v upon v is equal to modulus of delta r upon r. आप दो ट्राइंगल की एक जैसी साइड का रेशियो बराबर बेस लेंथ इक्वल बेस लेंथ टू दी साइड लेंथ, तो इस तरह से एक ट्राइंगल के लिए बेस लेंथ अपॉन साइड लेंथ इज इक्वल टू दूसरे ट्राइंगल के लिए भी बेस लेंथ अपॉन साइड लेंथ। तो बेस लेंथ यहाँ पे आपको डेल्टा v अपॉन v मिल्स अपॉन साइड लेंथ v, एंड दूसरे ट्राइंगल के लिए मॉड्यूलस ऑफ डेल्टा r अपॉन r इज देयर। इट मींस व्हाट? चेंज इन वेलोसिटी वेक्टर, मॉड्यूलस ऑफ डेल्टा v इज इक्वल टू क्या? ये v आ जाएगा, तो v अपॉन r इनटू द मॉड्यूलस ऑफ वेक्टर डेल्टा r। अभी डेल्टा v को डेल्टा t से डिवाइड कराइए तो आपको एवरेज एक्सेलरेशन मिलेगा, साथ में डेल्टा t टेंड्स टू 0 लीजिए, तो ये द मॉड्यूलस ऑफ vector a is equal to limit delta t tends to 0 delta v upon modulus of delta v upon delta t. So modulus of delta v can be replaced by this equation v upon r into modulus of delta r, and now here it is divided by delta t. Bring this v upon r in front side. Therefore this acceleration being in the direction of center, centripetal acceleration equal to v upon r limit delta t tends to 0 of modulus of delta r upon delta t. But this one is known as you know, the magnitude of velocity, that is speed v. So AC is equal to v upon r into v, that is v square upon r. So the centripetal acceleration is always AC equal to v square upon r. Now there is another method, and according to this method again we can see as the object moves on the circular path and it goes from P to P dash in the time interval from t to t dash, that is delta t, then it shift to that line Cp is going to be shifting from Cp to Cp dash. That why it occupies, it covers the angle delta theta. As the object moves from P to P dash in time interval delta t, the line Cp turns through an angle delta theta. So from the figure you can say that delta theta is known as what now? Angular displacement of the object. At the same time, you can define the angular speed. तो जिस तरह से लीनियर स्पीड इक्वल टू लीनियर डिस्टेंस अपॉन टाइम इंटरवल, तो एंगुलर स्पीड इज इक्वल टू एंगुलर डिस्प्लेसमेंट अपॉन टाइम इंटरवल. तो एंगुलर स्पीड इज डिफाइंड एज the time rate of change of angular displacement, and this angular speed is denoted by the symbol omega. So omega equal to angular displacement upon time into delta t. If the linear distance, अब वही पार्टिकल p से p डैश पे जाता है तो कितना linear distance ट्रैवल करता है, लेंथ ऑफ आर्क pp डैश कितना, और वो लेंथ ऑफ आर्क pp डैश को हम डिनोट करेंगे बाय सिंबल डेल्टा s, and that linear speed upon time interval gives linear speed. So if the linear distance traveled by the object in time interval of delta t is delta s equal to arc pp dash, then its linear speed v is equal to delta s upon delta t. But we know that angle delta theta, अब ये एंगल डेल्टा थीटा था और यहाँ पे आर्क pp डैश है, रेडियस r है, तो एंगल इक्वल टू क्या, लेंथ ऑफ आर्क अपॉन रेडियस, लेंथ ऑफ आर्क मतलब डेल्टा s. तो but angle delta theta equal to delta s upon r, that means delta s equal to r into delta theta. So you put in this equation, तो v equal to क्या है, delta s upon delta t, delta s के बदले में r into delta theta upon delta t, but this delta theta upon delta t is angular speed omega, so we can write linear speed v equal to r into angular speed. This equation shows a relation between two speed, one is linear speed, another is angular speed. So v is equal to r into omega. R is radius of a circle and omega is angular speed. So substituting this value v is equal to r omega in this equation. Centripetal acceleration is equal to v square by r. V square by r मतलब r square omega square upon r. The one r will be cancelled. So it is r omega square. So in this way, this is another equation of centripetal acceleration, and it is r omega square. First one is AC equal to v square upon r.